Good afternoon, everyone. Welcome to ed350 Curriculum and Pedagogy 2, Micro Teaching 2. I am Philip Brooke, biology from Netherlands, and I am majoring in teaching secondary mathematics. Today I will do my presentation on an interesting topic in year 11, mathematics, called the factor. Now, I didn't assume factor, but in other areas that we will discuss in the next classes. The focus of this particular lesson is calculating the magnitude and the direction of the factor. This means the overall objective of the lesson is that students should be able to define what the factor is, explain the importance of factor in mathematics and real-world applications, define and calculate the magnitude and direction of the factor. Additionally, the expected outcome is that students will be able to have deeper understanding of factors, their magnitude and direction. On the outset, how do we define factor? Now, understanding the two terms which are commonly associated. A factor is a mathematical object that has both the magnitude, the size, and a direction. The length of the arrow represents the magnitude, and the direction of the arrow indicated its direction. Example, a displacement factor, velocity, force, and acceleration. Now, the displacement factor, for instance, working 3 kilometers north, 3 kilometers is the magnitude and the direction is north. Okay? Now, on the other hand, there is a scalar. It only has a magnitude but no direction. Example, the temperature, which only tells us about how hot or cold a place is, but no direction. Also, the speed only tells us about how fast in each time, but no direction. So those are the two words, the scale and the factor, and their difference. But then the focus for this particular lesson is on factor. Now, what are the common factor notations? Now, from the notes that I should give you, you should have the factor. Take note, there is a V, and right at the top of that V, you have an arrow there. Okay, that arrow indicates its direction. Okay, and then you should have there, we have the X component and the Y component we should have there. Okay, take note of that one. Now this is for the 2 dimensions. As you're moving up, you'll do maybe 3 dimensions factors. We have X, Y, and Z. Now, how important is understanding factor? Factor applied in real life. It can be used in fields of physics, engineering, and computer graphics. Understanding factor is crucial for advancing in more complex topics like factor calculation, the real-world problem. Now, how do we calculate the magnitude and the direction of factor? And this is the focus of this lesson. Now, you can see from your note that I've given you, there is a formula given for you. To calculate the magnitude, take note you have something like an absolute there, and then V, take note, and then you should have the component of X and Y there, in the 2-dimensional shape. And then the idea of Pythagoras theorem is applied here, student. Now, take note of that example, factor equal 3, 4, find the magnitude. So we apply the Pythagoras theorem, we have x squared plus y squared. But in our case here we have 3 is x, so x squared 3 squared plus 4 squared. That gives you 9 plus 16. That's equals to 25. Okay, and then you square root that, square root of 25. That's equals to 5. Okay, and that is the magnitude of the factor. Now, with that, the other important calculation, like I said, direction. Take note we have the direction there, the angle theta, you're supposed to have from that line, okay, you have there, so you have your direction, the right angle there, so it's 4, it's what? We have 3, 4 here. Okay, this is the angle. Now take note there, XY, the x-axis, take note the positive x-axis, okay, is very important because the angle that we will get, you take the positive x-axis as the original line, okay, and then you go counterclockwise to find that angle for the direction. Okay, so you have there to find that angle theta, tan of that angle theta, take note, tan of that angle theta equals to 4 on 3, that gives you 1.3 something. Okay, to find the angle theta, take the inverse of that angle 1.3, and that gives you 53.3 degrees. 3 degrees, that 53.3 degrees is the what? Is the direction, okay, in which you should take. Okay, so that is how to calculate the magnitude and the direction. Now, there is a class activity which I decided for you, factor exploration with real application. Take note, before doing that activity, I'd like you to take note that factor, there are examples of factors that you apply in our daily life. Such as working from one direction to another. Or maybe a form of force applied when you open a door. Okay, and there are other examples on that one. Now take note the importance of magnitude and direction and their connection in real life. Like for instance, we have the navigation. Okay? The magnitude, or when a ship or an airplane is traveling, refers to the distance in which it's covering kilometers or miles. That is the magnitude. And the direction, take note, is coincidence that the ship or the airplane is heading towards the correct location. Okay, for example, like navigating from Somalia to Fiji, it requires knowing not just how far the magnitude, but also in which direction to travel. Maybe the east, southeast, for instance. So this means, without knowing both the magnitude and the direction, it will be impossible to reach a specific destination accurately. Okay, so therefore, class, it is important that you fall into groups of 4, and you should have these items, maybe graph paper, ruler, marker, protractor, rocks, exercise books, and pencil. Okay, we should also do that one. And then take note from where you sit down. Okay, it's good that we represent factor. Now, I'd like us to do that one. There is a way, there is an example. I'd like you to walk 4 meters east and 3 meters north. Okay, so student, try to represent this 4 meters east and 3 meters north. Okay, now it's good also to use your graph paper there. Okay, and there is a scale that's given 1 centimeter, 1 meter. Okay, but take note we have there. Okay, you can use this scale, protractor. Now, in a graph paper, try and apply that. Okay, the centimeter there, 4 meters. Okay, so 4 centimeter east, and then 3 centimeter north. Okay, 3 centimeter north. Okay, try and apply that. You can move from your desk, okay, eastern direction and then to the northern direction. Now, try and measure that 4 centimeter accurately using your ruler in your graph paper. So 4 centimeter to the east and 3 centimeter to the north. Okay? Now, after you get that, it's good to make it accurately. You measure from the starting point to the ending point. Okay? If you measure that student, I know in a group, you should find that there should be 5 centimeter. Okay? 5 centimeter. Now, take note, if you apply it in the real world, maybe you measure all this 4, So you should go, like we have 4 centimeters, it should be 4 meters. Okay, and then go up north, it should be 3 meters. Okay, then you find the magnitude of that factor. Okay, so take note of that particular one. This is important. Okay, then after, take note for the direction there. Okay, after you find this one, it should be 5 centimeters. Now from there, you calculate for this angle. Take note the tan of this angle. Okay, it's what? 3 on 4, so it's around 0.75. Okay, the angle, take the, use your calculators, take note, 0.75. That should correspond to one value, which is around 1. Okay, those will be coming up with that solution. That it should around 37 point something, 37 point yes, 37 degrees. Now, take note on that one, class. Okay, you can see from the group work that you have done. You see from the north, this is 4, this is 3 centimeters, and this one is 5 centimeters. Now, once you apply this calculation in the real calculation, in the formula, you will come straight same exactly to this one, 5 centimeters, no difference. Now, this particular angle here, if you do that accurately, take note, if you do a protractor, get the protractor, you measure. Okay, and you measure from the original one, you measure from here, and then goes up to this. Okay, you will see that the angle is around 37 degrees. Angle is around 37 degrees. Okay, so take note of that, and that is how you should calculate for this particular exercise. Now, take note, student, this is how we should calculate for the magnitude and also for the direction. Okay, so take note on that one. So you can see from the example, and you can see from this activity that you have seen there, to calculate for the magnitude, the components are very important. The x component and y component. Okay, because those two components, you will square them and then you add them, and then you square them, then you should find the magnitude. And the same component, take note the tangent ratio, opposite over adjacent. Okay, then you should find a value of the tangent angle, get the inverse of the angle, then you should find that angle, which is the angle of that direction from the positive x-axis. Now take note, student, that is the activity. In our next class, we will cover some of the same practical exercise like that so that we understand what factor is. Okay? So take note, if you have any question, you can ask. You can ask now because you are running out of time. Okay? But if there is no question, take note from the example understanding and from the task that I've just given you. I've just given you the answers for that. Take note. I believe you can perform or you can do activity B on page 6, questions A to E. Questions A to E. Now you can continue those questions for your homework. Now, with those, thank you very much, students, for your participation in our class for today. I believe in our next class we will cover some of the questions that came in application of factors, as well as some of the questions, especially on the bearing, not the bearing, but the direction, and also the magnitude. Okay? So until then, wish you